for everybody's taking the time to attend the session with us today, and we are very privileged to have Pavel Brook to present to us today the product methodology around MBSE. Some of you might know myself. I'm Lara van Niekerk. I work for Qfunsoft, and we're the sole suppliers of Ansys simulation software in Southern Africa. And we have, as I said, an Ansys expert to present the Ansys methodology to you today. So, Pavel, over to you.
Thank you, Lara. Hello, good afternoon, everyone. So thank you, Lara, for the introduction. So today I'm going to talk about our MBSE approach at Ansys together with various tools and as well methodology we provide. So the agenda for today would be the following. So we will quickly discuss of what is MBSE, because there are a lot of different terminology around that. There are a lot of different activities going on around this. It's becoming very popular direction now in the engineering world. So we will discuss why it's important and why it makes sense to look at this more precisely. We will talk about Ansys ecosystem around MBSE. And of course, I will mention the Ansys tools which enable MBSE approach and as well as support MBSE approach. And then we do conclusion, and if there will be any questions, I will be glad to provide you with the answers. So let's start with the details. Let's start with definitions. What actually we mean under MBSE. So MBSE stands for Model-Based Systems Engineering, and there are basically two parts of this, as you can see. So one is systems engineering, and systems engineering, just to remind, is we call systems engineering a certain approach for the complete life cycle of the system, which includes its design, realization, technical management, operations, and retirement. And this is the methodical and multidisciplinary approach. So MBSE, so model-based systems engineering, is basically simply systems engineering, which is based on the particular models. So we want to switch from document-based approach to systems engineering to a model-based approach to systems engineering, where basically we use the definition of model as the key single unified source of data for everyone during this life cycle. And what do we mean by models? So model in MBSE is a detailed description of the system being designed, and as well as it's the engineering analysis and tools to ensure that the system meets the requirements. So we use system architecture model to describe our system, subsystem, or particular components of that system. So what do we want to achieve? We want to achieve with MBSE a transition from the island approach, engineering, like siloed engineering approach, to a collaborative engineering approach. And we are using system architecture models as an authoritative source of truth for all participants of our processes. And it helps various engineering domains like design, assemblies, research, development, tests, operations, to basically communicate, interact, and integrate their activities using this single source of truth and using this model. So what are the benefits of MBSE? So with MBSE, we want to achieve the improvements in the product development processes. And the model-based approach helps us to work with the complex systems. It helps us to reduce cost and schedule, and therefore to reduce the risks. And it helps us to design better products with better performance. So if we look at this from like the communication point of view, from the point of transitioning from traditional engineering to a digital engineering. So what we want to achieve, we want to move from the state when you have different disciplines and different people are communicating without having the single definition of the product on a system level. So we want to, by introducing the model as the authoritative source of truth, we basically place this model in the center of this communication, and we assign this as like a master model for all disciplines to communicate. So if you have an experience of working with, for example, 3D models, 3D CAD, so you probably know the concept of associativity and like a 3D master model when you design, when you create the 3D model of the product, and then you can use this 3D model for creating drawings, for creating assemblies, for creating the toolpath for numeric control machines, for making meshes for engineering analysis. And as soon as you change your 3D model, then everything is changing associatively. So that's exactly the same approach. So you use the model of the system as a single source of truth, and you connect all the disciplines. And if something is changing in the model, in the requirements, you always can see the influence, how these changes are influencing other disciplines. So you get collaborative environment, agile, connected, and traceable, where when you are able to get the right information in the right time, the right format. So if we look at this like more in the from the life cycle point of view, so you all know probably that the cycle diagrams. So when by introducing the systems engineer, like model-based systems engineering, we basically start from the very beginning. So by introducing it here on the very early stages of the design life cycle, we are able to influence all other processes and all other stages of this life cycle. And we are always sure that we never forget anything from our systems or subsystems definition. We never forget any requirements which are connected, obviously, with that systems. And we, at every point in our life cycle and every point in our V cycle, we always can refer to the data we have in the model. So looking at this like in more linear manner, so we with model-based systems engineering, we want to make a transition from the situation when we have a document-based environment, and by document-based, I mean not just the paper documents. It can be electronic documents, but still, it's just disconnected documents, just separate files or separate links without any traceability across the life cycle. And with such approach, we have disconnected processes. We have design defects identified very late in our life cycle. We have design defects introduced by just having not connected with initial requirements to the product. We have limited capabilities of design optimization, and so on and so forth. So with model-based systems engineering, we introduce connected processes. We are able to introduce multidisciplinary analysis and optimization processes, which will help us to identify and resolve design defects earlier in our life cycle. It allows us to do test planning, and it allows us to do a minimal amount of design changes and introduce the minimum amount of failures to our system. So with that, what is basically MBSE? So MBSE is not a particular tool. MBSE is basically a methodology. It's the set of documents which describes you how you organize your processes in your company, how you create that authoritative source of truth for requirements, for system structure, for interfaces definition, and so on, how you capture that structured digital artifacts and manage these artifacts across the life cycle. So once again, MBSE is not a particular tool which like you can install and deploy. This is a methodology which includes various tools, different sets of processes, different approaches to that particular methodology across your organization. So just to conclude what I've just said, so we with MBSE approach, we would like to create the environment which will put our model in the middle of our processes. So when we create our system architecture and then inherited physical design, logical design, functional design, software design data, and connect the system architecture with requirements, both system requirements and stakeholder requirements, and then we ensure that we are able to do iterative refinement of requirements, of the models, to use this information during all product lifecycle phases, that we have a systematic objective analysis, that we use this model as an input for our design and for any kind of design, including even like, for example, software architecture models, that we use this model in a standardized way. And for that standardized way, we have to use a particular language which describes this model, and that this language is understandable for everyone across our organization. And of course, last but not least, we need to have a tools which supports this methodology, which helps us to automate tasks, to keep consistency between different abstraction levels, and to basically provide this working environment. So with that, Ansys have the special ecosystem and the product strategy around MBSE concept. So the products which are provided by Ansys is a open solution which is built on the open framework with based on the up-to-date standards. So as you could see from our model-based set of products, we are always based on the current industrial standards. That's the collaborative products, that's scalable and consistent products, and it integrates with best-in-class tools like, for example, engineering analysis tools, physical solvers, and so on. So what actually we are offering here in this context, let's start from the system architecture model, of course, because we just discussed that this system architecture model is the core of model-based systems engineering approach. So we need to create a shared view of a system using the unified language, which is understandable for all stakeholders and which will serve as an authoritative source of information, of requirements, of design, verification, and so on. So for that, we have a product which is called Ansys SAM, System Architecture Modeler. SAM is able to model and refine different kinds of architecture. So it can be functional architecture, physical architecture, software architecture, using the single language. In our case, that's SysML. And it basically serves as the general purpose system architecture modeling tool. Ansys SAM is based on version 2 of SysML language, which is a completely new version of this language. It's the latest and most powerful version. It provides the seamless exchange of the data between various modeling tools. And it's, as I said, it's the latest version of the language, so we are sure that this version incorporates the latest capabilities of the systems definition, and it is much more convenient to use for system architecture modeling than the previous versions of this language. Ansys SAM is web-based, so it can be accessed through the web browser. There is no special installation required. It's a scalable product, and it provides you with the capabilities of the real-time collaboration. So you can work on the same model, different users. You can see what these users are doing, and it provides you with open infrastructure and in order to integrate any kind of tool to implement MBSE concept. Because as I maybe not said in the beginning, so it's not enough to have the model. So model is not the only requirement for MBSE. So you need to connect this model with other tools, with other workflows. So if you don't do that and you just have the model, so just the model is not MBSE. Together with SAM, we also provide you with MBSE methodology. An MBSE methodology, that's a set of documents developed by Ansys, which are also created partially using the definitions of SysML v2. And this is a separate product of Ansys, which we provide to our customers, which helps you to establish your own MBSE related workflows, MBSE related processes, to reduce the errors, to enable all your stakeholders to participate in these processes. And it's also open and extensible methodology, so you can inspect it, you can modify it, you can customize it according to your standards or according to your processes. So just a note why we are based now on SysML v2. So we believe that SysML v2 is significantly easier to learn, easier to use, and more powerful than the previous versions of SysML. So comparing to v1, it's more precise, it's more expressive, it's more intuitive and regular, more consistent, and it's claimed to have a better interoperability with other engineering models and tools. So our SAM is based on SysML v2 now. Okay, so we've created the model. Then what's next? Next, we need to connect this model with other tools, with other stages of the life cycle, with other processes. And this gap between system architecture modeling and simulations and other engineering processes It's very well known, and by bridging this gap, we are able to achieve the true MBSE implementation and get the MBSE related advantages, right? So for that, what you basically want to do, you need to connect system architecture model together with the requirements you already have, with the modeling and simulations, and also do multidisciplinary analysis, optimization, trade studies, and so on. So for that, we have a product which is called ModelCenter. So ModelCenter is designed to cover three key areas. It allows you to create automated workflows. It allows you to perform various trade study analysis and design optimization. And last but not least, and very important in context of our discussion, is to connect these simulations to system models. So ModelCenter is unique in terms of creating and automating various analytical models. So it's built the way that you can connect any engineering tool or any other tool to the workflow. So you basically can create the kind of the black box, which describes the particular application, which accepts the particular input values, running the application, executes the activities you want, executes the tasks you want, analysis you want, and then provides you with the output values, which then can serve as an input to next stage of the workflow. So if we see how it can look like, so it can be, for example, you take a particular data from PLM system, then you send this data to CAD, then you do some calculations in CAD, then you send some data to engineering analysis, then you send some data to, say, system analysis, to cost analysis, you can create a very complex workflows here. And this way is how you automate your analysis and simulation activities. You can build very complex parameterized workflows for the particular use cases. ModelCenter is a very strong automation platform. It's very easy to use. It's tool agnostic, so you basically can integrate any kind of tool here. And it supports collaborative engineering work across your networks. The second possibility of ModelCenter, second set of functionality of ModelCenter is design space exploration. And here you can do various, after you create this workflow, you can then run it multiple times to execute the particular trade studies, design optimization, and do various using wide range of algorithms and exploration methods built in ModelCenter, and such types of analysis like sensitivity analysis, Monte Carlo, probabilistic analysis, and so on and so forth. So ModelCenter helps you to select very automatically various kinds of methods, exploration methods, optimization algorithms, depending on the task you want to run, depending on the input and output parameters you want to put in. The very interesting example in conjunction with this functionality is the trade study in the military aircraft design from one of our customers, Northrop Grumman. So you can see here there are very complex workflow for multidisciplinary analysis and optimization of the on the initial stages of design to make the balanced aircraft design. And what they've done, they've created the workflow in ModelCenter, which includes various disciplines and various tools like design space definition, like propulsion, subsystems design, structural design, aerodynamics design, mass properties and performance analysis. And as a result of this trade study, you can see here on this video, where you can see in the ModelCenter environment how this workflow is running and how optimization algorithms are working by changing the wing panel sweep degrees, by changing the number of engines, and by trying to find the optimal field of data for the optimization task, which was set up in this workflow. So that's a very powerful mechanism which helps you a lot on the initial stages of design, as well as further in a detailed design. And of course, that would all not be full without connecting all these workflows to our system architectural model. So that's the third and probably the most important functionality of ModelCenter, when we can connect our system model to our simulations by using a special plugin, which is called ModelCenter MBSE, where you actually can read the parameters from your SysML model, including requirements, including all kind of attributes, and all blocks, parameters, and connections, and link this data to your analysis data, to your analysis variables, to your input and output parameters, to your workflow. And then obviously you can also run this inside your workflow, and you can immediately see how your optimization algorithm, how your optimization workflow is influencing your model, how the changes in the model will influence your design, and how you satisfy the particular requirements which was defined in your system architecture model, and if you satisfy that or not, and what we can do with that. ModelCenter also has the in connection with our other product, SDK. It provides you integration with sort of behavioral execution engine, when you can basically use state machine diagrams in SysML to simulate the behavior of the system. So you can basically run to execute the particular SysML model, and with VE you can see how system is how system is changing. You can run trait studies, taking into account various physical characteristics, mission performance, and so on. Okay, so to conclude our today's discussion, so with what we see here is basically Ansys portfolio and Ansys ecosystem for model-based solutions. So we have in the middle the system model, which is managed by SAM, our system architecture modeling tool, which is connected with various requirements management systems. So we integrate with all major requirements management systems here. And then by utilizing this model as a single source of truth, then we use this model in all other Ansys applications, starting with ModelCenter, as we discussed, for engineering analysis, for verification, for optimization, and then obviously with further into the design lifecycle to data configuration management in Minerva, to our 3D physics solvers, as well as our specialized tools for safety analysis, like, for example, Medini, for cybersecurity analysis, with our specialized tools for design and verification of critical embedded software, like SCADE, with our digital mission engineering tools like SDK, including behavioral execution engine capabilities, as well as with our digital twin concept and our twin builder application, which helps you to define and execute various digital twins. So to conclude, what we've discussed today, so we discussed on what is MBSE, and we came to the point that this is a transition from siloed engineering approach to a collaborative engineering approach using system architecture model as authoritative source of truth. It helps different engineering domains to communicate, interact, and integrate together. So we need MBSE because we want to manage the increased complexity associated with today's very complex systems, cyber physical systems, and so on. We want to reduce cost. We want to reduce our time, and as the consequence, we also reducing our risks. And of course, we want to design better products with better performance, quicker, faster. So Ansys provides you with MBSE ecosystem, which is open solution. It utilizes up-to-date standards. It provides you with a collaborative, scalable, consistent, best-in-class environment and engineering tools. And we also discussed key Ansys MBSE tools, which enables MBSE approach, which is SAM, System Architecture Modeler, based on System LV2, and helping you to create the models. The ModelCenter, which is a multidisciplinary analysis and optimization tools connected with these system models and enabling bridging the gap between the system architecture phase and all other phases of our life cycle. And as well as we also provide a set of model-based tools like embedded software design, SCAPE, like safety and cybersecurity analysis, or Medini, and also other tools for digital twins, for engineering analysis, data management, and mission engineering. So with that, that's it from my side. Thank you very much for your attention, and we have some time for the questions.
Thanks a lot, Pavel. There's a very good thorough overview. I think there might be people in the audience who hasn't been exposed to MBSE before, but thanks a lot for that overview. I'm going to stop recording now.